Hi, everybody. It is the third Sunday of July, and I just wanted to touch base with you on this nice, cool Sunday about the Globe Earth or Glober's fairy tale. So I am titling this little video, In Your Fairy Tale. So, Globers, in your fairy tale, how fast does the earth revolve around the sun? In your fairy tale. Now, Google tells us it's 30 kilometers per second or 66,600 miles per hour, 666, just consequently. So, but every interferometer experiment since Michelson, Morley, Dayton, Miller, and so on and so forth has shown no more than 3, 5, 6, or 8 kilometers per second. So we're told 30 kilometers per second or 66,600 miles per hour, but science tells us 3, 5, 6, or 8. So it's a fairy tale that you're going around the sun at 30 kilometers per second. And the 3, 5, 6, or 8 kilometers per second can easily be explained by the sidereal rotation of the sky, translating motion down to our good Earth, our God-created good Earth. So, cool story, Globers, 30 kilometers per second. In your fairy tale, what is space-time or space-time curvature? What did they come up with November 6, 1919? What did they do? Well, they saw 2 out of 36 plates that they took from the May 29th, 1919 eclipse of the sun and said, hey, we are going to find 2 out of 36, or we did find 2 out of 36 that had, hey, this proves space-time curvature. So we're going to leak it to the USA and UK press on November 6, 1919, that Einstein's our boy, and Einstein wakes up November 7th, the guy who saved the ball going around the sun. Cool story there, too. In your fairy tale, how far in miles is a light year? Remember Buzz Lightyear? Cool children's story. Buzz Lightyear. So it's 5.88 trillion miles. Light travels 5.88 trillion with a T miles in 1 year. Cool. In your fairy tale, how can you have gas pressure without a container? Now we're told gravity holds it all down to the ground on your fairy tale globe. But if you had actually an open system, which we're told where you can go up until you get the vacuum of outer space, which is 10 to the negative 17 torr, and it hasn't been measured here terrestrially on Earth more than 10 to the negative 6 torr, which is 11 more zeros. That gravity, which is a weak force, if it's a force at all, depending on who you talk to, holds that all down, and all the air which we breathe wouldn't rush out into the vacuum of outer space. Cool story, bro. God bless gravity. God bless gravity. Something we can't measure. We don't know what it is, but hey, we can't measure it, but it keeps the globe fairy tale alive, that gravity. In your fairy tale, why isn't the moon too bright to land on? Now, if you go by science, the inverse square law of light, for every time that you make something half as much as far as the distance, it increases the light by 4 times. So, in your fairy tale, the moon is 240,000 miles away from the Earth. So if you half that to 120, half that to 60, half that to 30,000, half that to 15, half that to 7,500, half that to 3,750, half that to 1,875, half that to around 1,000, your moon should be approximately, now get this, 65,000 times brighter, 65,000 times brighter than when you look at it here terrestrially on the Earth from 240,000 miles away. Now, I remember Apollo 11, 12, 14, 15, 16, 17, because I'm old enough, that it wasn't bright up there for Neil on Apollo 11 and Buzz. Not Buzz Lightyear, Buzz Aldrin. So I want you to know I know who the difference is between the two. So, let's forget science. Let's forget the inverse square law of light. You know why? Because we got to have our globe and we got to have outer space. Cool story, man. Cool story. Cool story. In your fairy tale, how can you see Saturn from 750 million miles away? Now, if you believe NASA, of course we all do, right? Yeah. If you believe NASA, then they have like this photo that what the sun would look like from Saturn, which is like 750 million miles away. They have this photo of what the sun would look like, and it's a little pinprick. It's just really, really small, man. It's really small. It's like really small. It's like, take the end of this little pencil right here. It's about as big as that right there. And from 750 million miles away, it lights up like we see it in the sky, right? We look at it and we see the rings. Now, the inverse square law of light says if you take something and double the distance, it becomes 4 times less bright. So if we're 93 million miles away from the sun and Saturn's out there 750 million miles away in their fairy tale, then let's double that, make it 180 million. Let's double that, make it 360 million. Let's double that and make it 720 million, close enough to 750. So we can see the moon right here as well, and we're close to it, 1,000 miles away, the same. And we can see Saturn, which is 750 million miles away, the same as we see it in the sky. Cool story, bro. Science is so wonderful. Inverse square law of light is so wonderful, we ignore it. That's how wonderful the inverse square law of light is. In science, we ignore it. Cool. You know why? Because we got to keep our globe fairy tale alive. In your fairy tale, can you prove the lights in the sky are multiple light years away? No. They say stellar parallax, but guys, come on. We're talking about 99.9999999999999, 89.9, and it's just unbelievable, man. They were supposed to believe, going all out those decimals, that it's like 0.1 of something that's got 20 decimals behind it. Cool story. Cool story. Anyway, stellar parallax, that's a discussion for another day. In your fairy tale, how does light bend? Well, it bends because gravity causes light to bend towards the ball, we're told, and because we think that light enters molecules basically at the top of the molecule and bends downward, and it does that consistently enough that it doesn't have to worry about going to the middle side, bottom of the molecule. It always pretty much goes through the top and bends down, gives us your ball, right? And if it's 7/6R, we'll just add a few more 100% to it so we can have our ball, right? Cool story, bro. Cool story, Globers. In your fairy tale, do large bodies of water at rest bend? Here we got a small body of water, but we're told, and it's level, other than me shaking around a little bit, we take this small ball of water and we move it out 2 miles that way and 2 miles that way where we can't see it anymore, then it starts to bend. And if we take it out real far that we can't see it anymore, it really starts to bend. Cool. Trust science that my body of water here is flat, but if it goes out to where I can't see it, then it starts to bend. Cool story, bro. I tell you what, guys. Anyway, it's a joke. Anyway, here we go. In your fairy tale, how and when was the bending and warping of space-time verified? November 6, 1919. Cool. 2 out of 36 slides. Lights bending close to the sun, and it verified space-time curvature. Cool story, man. And we can't even find those 2 plates anymore. How convenient. Next up in the fairy tale, we have, in your fairy tale, what is the supposed pressure of your fairy tale outer space? 10 to the negative 17 torr. Now, we haven't measured any more than 10 to the negative 6 torr terrestrially, which is 11 more zeros, but who cares? It's a fairy tale. I can make up whatever I want to make up. So, anyway. In your fairy tale, is the bending and warping of space-time physical or theoretical? It can be physical if you want it to be, because we found 2 out of 36 plates back in November 6, 1919, prove space-time curvature, thank you. Or we can say it's theoretical and just say, no, those guys back November 6, 1919 were just making stuff up. And it's all by theory. Cool, man. In your fairy tale, why are Einstein's field equations partial? You'd have to ask Einstein. I call him Ein, but because only his personal friends do. But you'd have to ask Einstein. And he died in 1955, but his spirit never went away, so I'm sure you can find him somewhere and ask him yourself. In your fairy tale, please explain Planck's constant to me. What is it? Planck's constant is 6.626 times 10 to the negative 34. Spell it out, 0.336626. Cool. And even Planck himself said it was an act of despair that he came up with it. That's a pretty good number, 6.626 times 10 to the negative 34. It's a lot of zeros, man. Lots of zeros. In your fairy tale, how was time dilation verified? Well, we got this little thing called, in 1960, where we got pound repka. No, pound repkas. You remember that one. Not really. But 1960 pound repka at Harvard's Jefferson Tower, a 22.5 meter tower, which is 73 feet 9 inches. They shot some photons up and down the tower, illustrating red shift and blue shift, and the difference was 0.000000736 meters per second. Now, I stood there with my stopwatch, because I was old enough. I was 2. Anyway, I stood there with my stopwatch, and I measured it, or somebody measured it, I don't know. In their fairy tale, you can measure anything, but 0.000000736 meters per second. That's a cool story, man. And then they had pound Snyder, a bunch of other things that I'm not going to get into right now. They have an atomic clock in Boulder, Colorado, 5,400 feet versus one in London at sea level. Then they have, you can supposedly age faster at 15,000 feet elevation than at sea level. It's all cool, man. I love fairy tales. I hope you love fairy tales too. I mean, I like Santa Claus. I mean, I probably believed in Santa Claus till 2 years ago. Cool. Anyway, in your fairy tale, when has length been contracted? Supposedly you had this guy named Lorentz in 1892 to help explain away Michelson-Morley that length contracted. Now, I do have a little show for you, because I'm into fairy tales, man. And so here's my fly swatter, and I get some little pesky flies once in a while. But, my fly swatter can expand like, Hubble's ever-expanding universe, but it can contract too. So I know Lorentz would appreciate my fly swatter that contracts. So anyway, this actually contracts. The other thing didn't contract. In your fairy tale, what is E equal hv? My goodness gracious. E equals, obviously, energy, and H is Planck's constant. 6.626 times 10 to the negative 34, and V is vibration, or you can put F in there for frequency. One side's got to equal the other. I ain't even go into that. That's just garbage. In your fairy tale, when is the sun closest to the earth? It is This is the third Sunday in July. The first half, or the first 2 weeks of July, the sun is the furthest away from the Earth in their fairy tale. It's over 94 million miles away in their fairy tale the first 2 weeks of July. In the first 2 weeks of January, it's the closest, at a little over 91 million miles away, because we have an elliptical orbit, and it's the reason it's elliptical and not circular, because a circular orbit in the math or the physics doesn't work, so they had to make an elliptical orbit to it. Cool story, bro. In the math, we got a ball, man. In the math, we live on something that kind of looks like this. Cool. So, here we go. In your fairy tale, I already mentioned this one. In your fairy tale, do people age faster at 15,000 feet or sea level? 15,000 feet. Just a little faster. No problem. It's science, man. Trust the science, right? In your fairy tale, what caused the Earth to be tilted at 23.4 degrees? So, we're told, science tells us, that 4.5 billion, with a B, years ago, that the Earth was, instead of being like this, was kind of like this, straight up and down, right? But then here comes something, it's called Theia, Theia. That's how you pronounce it. I really don't care. It hit the Earth just fine, that it tilted it at 23.4 degrees. It was a large asteroid, small planet. It hit the Earth just fine, and that tilted it at 23.4 degrees so we could all vacation in Florida, right? Because, being tilted at 23.4 degrees allows us to get out of those cold wintry months and go to Florida where it's nice and warm, right? So, cool fairy tale. But that's what happened. That's why we have our 23.4 degree tilt, is because of this big asteroid, which allows us to go vacation in Florida. Cool story, bro. Anyway, continuing on. In your fairy tale, how does a rocket push off of nothing? Let's see, here on Earth, Newton's third law of motion works just fine. You have a motion going this way, and you have an opposite medium pushing back against it. So you have a submarine going this way, and you got water pushing back against it. You got an airplane going this way, you got air pushing back against it. You have a car, you have a little bit of air, but mainly the ground pushing back up against it. You're a runner, and you have the ground, a little bit of air pushing up against you. All those things work out really great here on Earth, but what's a push off of in outer space, 10 to the negative 17 torr? I tell you what. It pushes off of nothing. But some people say they take the oxygen with them, because in outer space, for something to go this way and this way, you tend to need propulsion and ignition. And they tell you take the oxygen with you to outer space, you can get your ignition and propulsion. The burst is so big that it pushes it forward. And great story, man. Great story. But how does a rocket push off of nothing? We don't care. We're going to violate Newton's third law of motion, even though they tell us I don't understand Newton's third law of motion. Cool, man. And we're going to violate that. It's like we violated the second law of thermodynamics, because we want our ball in outer space. Just remember that. It's a religion, folks. In your fairy tale, what is mass increase? Time dilates. Mass increases. Length contracts. I can't keep it straight, but it's something like that. It's cool, man. It's cool. In your fairy tale, how is gravity measured? Is Newton gravity a law or a theory? Now, in the recent Tom Cruise movie, Maverick, that came out last summer, it wasn't a law or a theory, it was a rule. They actually called it a rule of gravity. So I guess is Newton's gravity a law or a theory or a rule? So instead of flipping a coin and getting heads or tails, now we got to find a three-sided coin to see which it really is. In your fairy tale, is the horizon physical or apparent? Now, If you are a globe believer and you want to have your cake and eat it too, it's both. We can't actually see it and we can't measure it, so it's an apparent horizon. It changes, right? Hour to hour, day to day. But it's also physical because you know why? We live on a ball, because I know we live on a ball. If I didn't live on a ball, my life would be really screwed up and there might be a psychiatrist I might have to go see. So my horizon is both physical and apparent because I can't see it, but I know it's there, so it's physical, and it's apparent because I can see the apparent horizon. Cool. Cool story, man. In your fairy tale, how do you measure refraction over large bodies of water? You take your imagination and you go, whatever it takes to get my ball. Whatever it takes to get my oscillating spheroid, my oblate spheroid, my planet, my sphere, my globe, whatever it takes, that's what I measure. So I take 7/6R and I need to add a few 100% to it. And I can even go out there a few 1,000%, 100,000%, whatever it takes for me to get my ball. Cool story, because I got to have my ball because it's a religion. I can't help. I don't pray to God because I'm an atheist, but I got to have religion. It's Mother Earth, right? In your fairy tale, who did Copernicus reference in his On the Revolution of the Heavenly Spheres? Hermes Trismegistus. Pagan sun worship. Okay. Hermes and I go back. It's cool. He's my spirit guide. So anyway, yes, Copernicus on the Revolution of the Heavenly Spheres, published May 1543. He referenced Hermes Trismegistus, sun pagan worship, and then he died the same month. Killed him off in the script, in my opinion. In your fairy tale, in what month, I just told you, I'm sorry. In your fairy tale, what month and year did Copernicus supposedly write a letter to the Pope dedicating his On the Revolution of the Heavenly Spheres to the world and also die? Gave that up before. May 1543. Sorry. God, I blew the last one, didn't I? Anyway, so I just wanted you to know that in your fairy tale, or let's reverse and don't say your. In the Glober's fairy tale, we're supposed to believe that we are a tilted, wobbling, spinning, curvy, bendy ball in the vacuum of outer space, going at these insane speeds. And don't worry about it. Don't worry. Be happy because your favorite NFL football team is starting practice soon and will have its first practice game in August and its first regular season game in September. Don't worry about it, whether you're a Dallas Cowboy fan, Philadelphia Eagles fan, Seattle Seahawks fan, San Francisco 49ers. Your favorite team is going to start soon. And you want to go out and have a nice steak dinner tonight. So don't bother me with things like the earth. And you've been lied to since birth or age 5 when you enter kindergarten. Don't bother me with that. I care if my NFL football team makes the playoffs this year, possibly the Super Bowl, because I have another couple weeks, to celebrate. Celebrate, good times, come on. Don't worry, be happy, cool. And I get my favorite steak dinner tonight. So anyway, thanks for listening. We'll have a few more going forward. Take care.